Kale, and today we're going to talk about 4.4 Earth's atmosphere. By the end of this lesson, you should be able to describe the structure and composition of the Earth's atmosphere. To accomplish this goal, we will identify the gases that make up the atmosphere and describe the layers of the atmosphere. So first we're going to talk about those gases. So as we learned in the nitrogen cycle, that got a little close. Nitrogen is our most abundant gas in the atmosphere at about 78%. This doesn't leave much for the other gases, but as one would expect, oxygen makes up about 20% of our atmosphere, and all that's left is for the other gases, argon, carbon dioxide, and then a little bit for any remaining gases. So our layers of the atmosphere. The layers of the atmosphere are based on temperature gradients, so changes in the temperature with altitude. So let's start with the closest one where we find ourselves is the troposphere. So Earth is right here. We notice that there's little clouds here because this is where our weather occurs, where planes are flying, this is where we are, and this one has the highest pressure, and that's because it has all the other layers above it. So we find here that as the altitude increases, our temperature is decreasing. So we have a decreasing temperature here, and that's because of the radiant heating of Earth. So we know that as sunlight comes in, it has different wavelengths. Some of that gets absorbed directly into our Earth here, and then re-radiated at a lower frequency to heat us up and to give us warmth. So as you get further away from the Earth, higher up in the troposphere, our temperature is going to decrease because you're further away from that heat source. Our next layer is the stratosphere. This is where we put our weather balloons. What we find here is that we actually have a temperature increase with altitude. So here our temperature is decreasing, and now our temperature is increasing. And this is due to the ozone layer. So we have a layer in here called the ozone, which is O3, which takes the UV energy from the sun and absorbs it. So it absorbs the UV light from the sun, which causes its temperature to increase. So the higher you get in the stratosphere, the higher your temperature is because of our ozone. Now when we move to our mesosphere, where we see meteors, we have again a decreasing temperature because now you're getting further away from that heat absorbing ozone layer. So we have a decreasing temperature, then our temperature is increasing, and again our temperature is decreasing. There's nothing in this mesosphere to absorb any energy, so as we move higher, our temperature is getting cooler. Next up we have our thermosphere. So the thermosphere is where you find things like satellites and our space station. You also can, this is where our aurora borealis takes place. So to summarize so far, we've got a decreasing temperature, an increasing temperature because of ozone, then a decreasing temperature because we're getting away from the ozone, and now again we have an increasing temperature. And this one's kind of tricky. There's not a lot of particles up in the thermosphere. There's some oxygen gas, but not much else. So it's actually getting warmer because the oxygen gas is absorbing that energy from the sun. And there's nothing there for it to give the energy to. So the molecules are moving faster, and by definition of how we define temperature as the speed, the average speed or kinetic energy of molecules, they're actually getting warmer the closer they're getting to the sun. So down here, our layer is getting warmer because of the ozone. Up here, it's because there's oxygen gas absorbing that light energy, and it has nowhere to put it, so those molecules, although few, are moving quickly and by definition are therefore warmer. Our last atmosphere layer is our exosphere. So the exosphere is pretty similar to the thermosphere. Again, our particles are very spread out, but again, they are going to increase in temperature because they are absorbing that sunlight. it's still going to feel cold to you in space because they're not transferring that heat. They're just moving really closely in their own little space. So to summarize, our goal was to describe the structure and composition of the Earth's atmosphere. We learned that the Earth's atmosphere is mostly nitrogen gas, and that some layers of the atmosphere are getting warmer with higher altitudes while others get colder. So this is a common diagram, you'll see that. So we have decreasing temperature, increasing temperature, decreasing temperature, increasing temperature, and then space is out here. Earth is down here.